Hello, and welcome to the second part in this series about installing Klipper, the 3D printer firmware, on almost any 3D printer out there. Today's video, we're going to be covering creating a configuration from scratch. We're going to be using my newly built RatRig V Minion here as an example. So we're going to cover how to create a brand new configuration for a printer that does not have one already, along with how you go about adding features or modifying features to an existing configuration. So let's get started. So first things first, there's some real good documentation on the klipper3d.org website that you're probably going to need to refer to often if you're creating a configuration from scratch or modifying an existing configuration. So if you go to the klipper3d.org website, go over to installation and configuration, and then go down to configuration reference. This page right here has pretty much all the examples and all the information you need to know about when it comes to adding features to your Klipper config or modifying something. So for example, if you want to have a secondary MCU, you want to run dual MCUs, this is how you go about adding dual MCUs. So you're going to want this page open. You're going to want this page bookmarked. It's going to have a ton of information that you're going to need and reference to. Some things to keep in mind. The way Klipper works is it is essentially just a configuration file saved on your Raspberry Pi. Now, one of the reasons I like the dedicated Klipper interfaces such as Fluid and Mainsail is you have the option of editing these files directly within the UI. So you can make your changes, hit save and restart, and they take effect immediately. So with our RatRig V Minion here, we don't have a configuration. I've gone ahead and created a printer.cfg file already. However, there is nothing in it. So we need somewhere to start. Now, while you can go ahead and completely create a configuration from scratch using the references, it's always good to start with something. Now, this could be, for example, using a base configuration of a printer that's similar to the one you're building. Or you can use just the basic configuration for the controller board. So in our case, we're going to start with the SKR Pico default configuration and add any additional features that we need to it. Now, there is an example configuration for the SKR Pico on the Klipper GitHub. However, we're going to be using the example configuration from the Big Tree Tech GitHub. So we're going to head and copy all of this, and then we're going to add it to our printer.cfg file. So we've added everything we need there, hit save and restart, and we'll probably get some errors because the default configuration is probably not fully set up. You're probably going to have to go through and adjust some values and potentially add some things to actually make it a functional configuration. So in our case here, we have an unknown pin chip name probe. So what I'm going to recommend at this point is go through your default configuration and just kind of get the basics set up. Get your printer moving, get your printer homing, and make it so that when you save and restart, you're not getting an error anymore. You're getting some temperatures and you're able to move some motors. So let's go through this configuration one section at a time, make it match our printer itself so that the information is correct. And I'll go over some things that you'll need to keep in mind when setting up the configuration itself. So first things first, our stepper X, and we already have some pins assigned to it. Now, hopefully at this point though, you've taken my advice that I've mentioned on live stream several times and wired up your controller board in a logical fashion. What does that mean? Well, if we take a look at the pin diagram here of an SKR Pico, the names don't really mean anything because you're just looking at pin assignments. So stepper motor E, for example, is really just pin IO15, pin IO14, pin IO13. That's all Klipper sees. We just gave it the name stepper E. We could change the assignment of this motor easily in the configuration. However, to make things simple, since this is called out as stepper E, I've wired it up as stepper E. Same with the thermistor for the bed, same with the thermistor for the hot end, same with my end stops. Basically try and make it match what the labeling calls out. While you can mix and match motors, you're just changing the pin assignments and the labeling in the configuration file. When you're creating your configuration from scratch and using a base configuration to modify, it'll make things easier because most stuff will already be set up and it just kind of saves a little bit of work. Now going back to our configuration here, because I've gone ahead and wired everything up to match the pin diagram from Big Tree Tech, and I'm using the Big Tree Tech default configuration for the SKR Pico for Klipper, I'm going to assume that my pin assignments for pretty much everything are correct right now. We may have to adjust stuff in the future, and we'll come across that when we come across that. Now below our stepper pins here for stepper X, you see we have micro steps and rotation distance. Now I'm running TMC drivers here, so I'm able to set my micro steps along with my currents via the configuration file. I don't need to play with jumpers or anything. But rotation distance, what is that? For those that are new to Klipper, Klipper uses rotation distance to govern how much movement you get out of a step versus step distance, which is what Marlin and RepRap firmware uses. So what is rotation distance? Well, if we take a look here at the Klipper documentation, they have a whole section on what rotation distance is. But basically, if you are familiar with setting your step distance, you had to do some math to generate your steps per millimeter or millimeters per step that you had to input. In our case here, we're just putting the values in and the firmware's handling the math itself. So on our x-axis here, I'm going to run at 16 microsteps. If I wanted to run at 32 microsteps, I would just type in 32 there. And rotation distance. Now what rotation distance is it's the amount of distance that the axis moves with one full revolution of the stepper motor. So at first this may seem a little unintuitive, but it's quite simple. On my x-axis, I'm using a 20-tooth pulley to drive my belt. And I'm using 2 GT belt, which the pitch is 2 millimeters. So 2 millimeters times 20 teeth equals 40. Right here, my rotation distance would be 40. If I was using a 16-tooth belt, it would be 16 times 2 would be 32 would be my rotation distance. Since this is a TR8-4 lead screw, it's 8 millimeters wide, and each full rotation is 4 millimeters. So my rotation distance would be 4. Extruders are a little bit more involved, and we'll come to that when we get to the extruder section. So I have 16 microsteps, 40 on rotation distance, and then my end stop pin. If you are using a physical end stop, you know, a clicky one, whatever end stop pin you are using for that axis, that's what you would put here. Now, in my case here, for my X and Y axis, I'm actually using sensorless homing. One of the things that I liked about this default configuration from Big Tree Tech is they have some options in here, but not activated. So if we want to go ahead and add sensorless homing to our printer here for the X axis, what we essentially need to do is just remove some hashtags there, and that will activate that line. And then we need to put a hashtag there to remove our end stop pin, because we're no longer using a physical end stop, we're using sensorless. Now, homing retract distance, we'll leave that at 0 for now, and position of the end stop. This is where the end stop is, and you'll probably have to tweak this value a little bit later, but essentially the way Klipper works for setting your distances, you want 0, 0 to obviously be on the bed itself for your printer movement. Now, where your end stop position is, it can potentially be past that point. So if you are homing your printer here on the y-axis, and you are homing it towards 0, but it actually triggers the end stop off the bed, say it was 5 millimeters past the edge of the bed, your end stop position would be -5. Now, if it's the opposite direction and it's towards the positive side, on my 180 millimeter bed here, say my end stop triggered at 183 millimeters, I would just set my end stop at 183 millimeters as its position. Now, obviously, when you go to set up your slicer profile, you're going to want to have your maximum X and Y distance obviously be the dimensions of the bed itself. You don't want to be printing in air. Now, this next section here is setting up the driver settings. So these are your UART pins. And again, we're going to assume they are correct because we wired it up matching the pinout schematic. And right here is our run current and our hold current. This is where you set the current for your motors. I would recommend running them at default values and adjusting accordingly. It really depends on what combination of stepper drivers you're using, what motors you're using, what speeds you're looking for. There's quite a bit to tuning your stepper motor currents, so we're just going to leave them at default values from now, and then later on, once we get the printer up and running, we'll adjust them. And then stealth chop threshold. This is the value at which spread cycle turns off and stealth chop takes over. Now, if you're like me, I don't like running stealth chop. I prefer spread cycle. I like the additional torque. And since my printers have their own room, I'm not too concerned about the noise. Also, there is a potential to lose accuracy when it switches from spread cycle to stealth chop and back and forth. So if you want to avoid stealth chop turning on, just enter a high value like 99999, and you'll never reach those speeds for stealth chop to become enabled. Now below that, we have some values that are uncommented. We're going to remove the hashtag there, and we're going to activate these. These are for the sensorless homing. So we're going to enable that. And then for the driver SGTHRS, I'm not sure what that stands for. That is your sensitivity for the sensorless homing, and you may have to adjust this value depending on how your printer is built and what kind of accuracy you're looking for with your sensorless homing. Now the next stepper is our stepper Y, and we're going to go through the same process that we did for our X-axis. Obviously, if any of these values are different, you may need to adjust accordingly. Now, as you can see right now, I am leaving my position end stop 0 for now. We're going to wait until we get the machine up and operational before we adjust the value of where the actual end stop position is. Our position max 180. Now moving on to our Z axis here, we're going to run with a micro step of 16. But again, I'm using a TR8 4 lead screw. So that means it's 8 millimeters wide, and each full rotation of the lead screw is 4 millimeters. So I'm going to change my rotation distance to 4. Now we aren't going to be using sensorless for our Z axis. We're going to have a end stop, and in my case here, we're going to be using a probe. If you were using just a traditional clicky switch fixed end stop, you would just set that up for whatever your end stop pin would be. You'd call out whatever pin you are using. But since we're using a probe on this printer, we're just going to leave it as probe Z virtual end stop here. This way, later on in the configuration, when we get to the probe section, we're going to set our probe up, and this call out right here lets it know that the probe is our Z end stop. Position min, this is a little bit under the bed. This allows for a little bit of over travel when homing. And then position max, again, we are going to adjust to 180. And of course, for our stepper Z, pinouts, we're going to leave the same because we're going to assume everything's wired up the same, and we're not going to adjust any of our run currents or our stealth threshold there. Now, when it comes to setting up your extruder values, the easiest way to go about doing this is to actually check the documentation for your extruder. Depending on what extruder you are running, doing the math to actually calculate step distance and everything may be a little confusing. So I'd recommend look up the documentation for your extruder, and hopefully there is some values for Klipper for that extruder. Now for the Orbiter 2 that I'm using, here is your firmware configuration for the stock setup. So we're going to go ahead and copy these values over to our configuration as a starting point. Again, you may need to calibrate your E-steps for your extruder in particular. The math for doing that is pretty much the same. You're adjusting the value for rotation distance when you do your calibration instead of adjusting your steps per millimeter. And then of course, if there is any additional documentation for your extruder that you need to follow, such as run currents and recommended voltages, make sure you are adhering to that. Now at this point, I'm going to call out something that I haven't touched on because it wasn't in the default configuration. You may not need to add this line, but this is the full steps per rotation line. And what this value does is it lets the printer know if it's essentially a 1.8 or 0.9 degree stepper. With a 1.8 degree stepper, 200 steps is one full rotation. With a 0.9 degree stepper, it is 400 steps for one full rotation. Now, default is 200. So if you're running 1.8 degree steppers all around your machine, you do not need to add this line. However, if you are running 0.9 degree steppers, you will have to add that line and set it up as 400, obviously. If you don't have the line, it's just going to assume you are running 1.8 degree steppers. Now, you may notice compared to our XYZ steppers, the extruder section has a lot more information there. And some of these things you may have to adjust. So with Klipper, there's quite a lot of parameters with the extruder, along with some safety features. So values such as inputting what your nozzle diameter is and your filament diameter, there are settings to prevent over extrusion and max flow rate. So if you're worried about accidentally choking out your extruder by slicing something incorrectly and trying to force way too much filament through it, you could set safeties in there. There are some default values in place that, depending on what kind of printer you're running, if you're running something fast like a Voron, you may need to update or increase those safe values. When you run across one of these errors, such as over exceeding max flow rate, it will pause your print and it will call it out in the terminal on Klipper. And as I referenced to at the very beginning of this video, the configuration reference section on the klipper3d.org website has all the information you would need about every parameter. So for example, that over extruding, that is your max extrude section right here. So yes, there is a lot of reading involved with setting up Klipper if you want to dive into all the options you have available, but it is well documented at this point, along with what you need to be looking out for and what values you need to adjust. Now moving down here, we have our sensor type. This is what type of thermistor you are running. Now there is a section here on the configuration reference page that covers all the different types of common thermistors you may see. So in my case here, I know I'm running just a generic beta 3950 type thermistor. So I'm going to update my value to a generic 3950. Sensor pin is of course what pin that thermistor is plugged into. And then we have PID values. Now, again, I would recommend leave these default for now. You're probably going to do a PID tune once you get your printer up and running. And when you save the config after running the PID tune, it will overwrite these values with the updated value. You have min and max temperature, so these are your safety values. So if the temperature drops under 0, it'll error out, and if the temperature exceeds this value, it will error out. I'm running a full metal hotend, so I'm going to leave it at 300 for now. And then we have a section here for the TMC 2209, and we're just going to leave this value default for now. Again, you may have to adjust your run current depending on your stepper for your extruder. Now, as you can see here, this is set up default with a filament runout sensor. I'm not using a filament runout sensor. So what you can actually go ahead, if you want to remove a section from a configuration, just add a few hashtags there, uncomment that line, and it won't look at that. Now, moving on to the bed heater. If you are running a printer without a bed heater, you would just go ahead and uncomment all of this section. But we have a bed heater here, so we're going to leave this section here. For the thermistor type, we're going to update it to the thermistor that we are running with this bed, which is an NTC 100 type. And again, with our PID values, we're not going to adjust those. However, I am going to adjust the maximum temperature. With this bed here, it is adhered with adhesive, and I don't want it getting above 120. So we're going to adjust our maximum temperature to 120. Now for the fans here, you can see we have fan, we have heater fan, hot end fan, and then we have heater fan, controller fan. And again, reference the fan section in the configuration reference section on the website for all the values that you may need to adjust for fan and heater fans, as well as controller fan and temperature fans. There's a lot of fan settings that you may need to play with, but sometimes you can just leave it simple. So this fan right here, this is your part cooling fan. And if you want it to just be simply turn on when called out by your slicer, all you need is the pin assignment. Now in my case here, I'm actually can't remember which fan is which. I currently have two fans plugged into this printer. One fan is a part cooling fan and one is the hot end fan. So we're just gonna leave the default pins for now. And then once we get the printer online, we're just gonna verify that I have the right pins in. And if we need to switch them out later, we can do that. And now for the heater fan, hot end fan, this is the fan that cools our hot end. And by having this heater underscore temp line here, this is when the fan kicks on. So what that means is when the thermistor in my hot end reaches 50 degrees Celsius, the fan turns on. When it drops below 50 degrees Celsius, it turns off. This is a very good feature to have on pretty much any fan on the printer, because if it's running constantly, that's just putting undue stress on the fan and it could lead to a shorter lifespan. Usually your fans, if the printer's not running and it's not hot, you don't need your fans on. And we have a controller fan. Same thing as our hot end fan. You could set it to turn on a certain temperature. Usually you tie this to, again, your hot end temperature, because if your hot end's not on, odds are your printer's not moving. Now these next two sections right here for MCU and printer, you may find these sections at the top of the configuration. I usually like to have those up near the top, but when it comes to the way a printer.cfg file is laid out, really the order doesn't matter of the sections, but for personal preference, I usually keep these up near the top. For the MCU section, this is basically telling it how it talks to the controller board. So when you go ahead and create the make firmware file for flashing the controller board, there's going to be a serial address, and this is where you would enter it here next to serial. Now in my case here, this controller is plugged in over UART. So this is what the setting I use for UART is, and the restart method. Again, this information may be called out in the example configuration for the controller board or the printer. Now for the printer section, this actually controls what kind of printer this is. So right now we have it set up as a Cartesian, and most stock configurations, you'll see it set as Cartesian. But if this was a Core XY printer, all we need to do to change this printer into thinking it's a Core XY is simply type Core XY and hit save and restart. And this printer will now think it's a Core XY printer and adjust the motion kinematics accordingly. but this is a Cartesian printer, so we're just going to leave it at that. Max velocity. This is for your maximum travel speeds of 500 millimeters a second. This might be a little too much for this printer. So say if we wanted to drop it to 300, we could just drop it to 300. Your max acceleration. This is for your X and Y axis. Unfortunately, you can't have them separate. They do need to be the same. So we'll just leave it at 3000 for now. And our max Z velocity. Now, since I am running a lead screw here, 25 millimeters a second might be a little too fast. So we're going to drop that down to 15 for now. Usually you don't need too fast of a Z unless you're running a nice fancy Voron. Now we do have some settings here for a BL Touch. However, we're not running a BL Touch, so we're just going to leave those commented out. And then this board has a neopixel on it. So you know what? Let's make this a nice green LED. This will serve as a visual reference, as once the full configuration is loaded after the whole boot up of Klipper, it will turn green and let us know the printer is ready to run. So this is the default configuration. This does not have everything we're going to need to run this printer yet, but this is just the default. So we're going to go ahead and save and restart and check for errors at this point. So as you can see here, unknown pin chip name probe. And I knew this error would pop up. I'm using it as an example. But if you remember earlier on, we were setting our Z extruder up and our end stop pin was going to be a probe. I haven't gone ahead and created a probe section. So I'm going to show you how you can add stuff to a printer. So say you had a printer, you had a traditional clicky switch Z end stop.